Okay. Okay. I will make sure that you will not get the sleep because my wife says I'm a very loud guy. My voice will be louder. You will not get the sleep. Hopefully presentation will be good. Now, moving forward, this is one society which we have set up in Hyderabad with, as Amlan Sen Gupta is talking about, Surya Prakash was the founder president, I am the founder secretary. Together with some other group of consultants have made this society, and so far I have conducted about 9 workshops across India, right? And then disseminating the knowledge about various construction technologies, not only precast. We started with precast, but then we have thought, okay, let us talk about all other construction technologies also. Then the people will have more ideas, right? So that's how we have started this. And then there are certain objectives, and then we have conducted lots of workshops, okay, at various levels. Since 2013, it has been active. Every year, 1 or 2 we have been conducting throughout the country. And one time MES people have asked us to conduct in Delhi, okay, asking us that we can't come to Delhi and sit there. But then when we have put up in Delhi, they have come and sat in our workshop, and then they have decided that, okay, wherever the precast companies are there in the country, they will call for tenders only in precast construction. That they are doing it now. That's how the precast construction into MES has gone very deep. Okay, that's where we felt very happy to do that. Okay, now we'll move on. You all know about the evolution of materials, right? We have been talking about normal concrete and high strength concrete. Now high strength concrete is now dethroned. Nowadays the buzzword is high performance concrete, right? High performance concrete and high performance steel composite construction. This is what it is. But these are the materials which are powering us to construct tall buildings. Tall buildings, because it gets more and more loads. They'll be able to take the loads. That is where it is. And then the tall buildings have the usual dead loads, live loads. I think all of you have been taught about this. But then the tall buildings bends. Tall buildings also bends due to the wind. Yeah, the Burj Khalifa, right? Burj Khalifa structure, Burj Dubai earlier, that bends by about 1.25 meter at the top level. 1.25 meter, daily it swings. Daily it swings. So for about 160 stories, right, it is made of concrete. The remaining 80 stories, it is made of steel. Because steel can take it can give the performance for ductility as well as fatigue. So considering those considerations, we have gone for the steel for the above structure. But we have seen that, and this building, after it is built, then we kept some people within the Burj Khalifa structure, every floor, and made the structure move like this. It has virtually moved right up to the top level, right? So that is a performance of the structure. And then having known this, then we have this wind performance of the buildings. We need to know much more about this, right? And then the wind vortex, they are the phenomena that will take care much into the tall building structures. I'll be just giving you a brief information, not go much into the details. It will not be possible to cover. And we know that, yes, a tree like this is a perfect cantilever. Our tall building is also a cantilever. Right from the building where we have got the fixity, where we are assuming it at the foundation level, right? Then it is beautiful to move around. This is how the people got the idea of it, right? And then any tall building that we design, we normally know what are the loads that are coming up. Okay, in spite of all this computer analysis and all that, we estimate what is the load that is going to come down. Okay, and then what is the earthquake load? Taking it as a stick model of the summation of the flexural rigidity EA values. Then we just put the stick model, apply the load on that as a cantilever, understand what is the moment we are going to get, what are the deflections we are going to get. That will nearly match with a 10% difference to the computer. That's what we do in all the structures. And everyone knows about the shear walls, the criteria, besides the columns and all, because shear walls, what we are taking is, they take the brunt of the wind forces and the earthquake loads. That's the reason why we go for the shear walls. I will show you some of the buildings at America or in Dubai, where I have worked for about 15 years, how the buildings have come up. Okay, most of the time, if we talk about 70 by 70 or 80 by 80, they will usually have a lift and stair core in the center, and then you have the peripheral columns. Okay, peripheral columns, and then we try to connect with outriggers if there is a necessity, or otherwise it is not required. Okay, this is how the tall buildings will be coming up, and Burj Khalifa as this is how the whole structure is made up, right? You have the buttresses, what we call about, yeah. If suppose the wind force or earthquake is coming up, these shear walls will take care of it. If that is coming up, these will take care of it. With the central core itself also have the shear walls. It will be able to take the load of that particular one. This is how the whole structure is done. But to give you the information, while it steps up, down like this, goes on, all this is taken care by about 50 wind tunnel tests that have been carried out on the structure at various levels. Because of the wind tunnel test data that we got it from them, then that fellow comes and says, yes, vortex are forming, eddies are forming here or here like this. Every time as the structure goes up, then we try to stop the structure there and then take it further. And then he advises, please raise the other side. And then we kept on increasing like that, reducing the sizes. Okay, so it is because all of us know that above 250 meters, okay, no code in the world covers the building, no codal provisions. It's all done with the wind tunnel tests and all. We went ahead with the design of this particular one. Right? Now, you can also see there's some irregular shapes of buildings which will be coming up like that. Even here, we have managed with these shear walls which are coming here to take care of the lateral forces due to the wind and earthquakes. Right? So just giving you that brief idea of what is shear walls, how they take care of in this thing. I just briefly run into the various technologies that have been ongoing in the country. Okay, predominantly this is the one which is now being adopted by the developers, monolithic construction. This monolithic construction is what is called as a Maiwan construction. Okay, because Maiwan is the guy, the fabricator who has started supplying this aluminum shuttering from Malaysia. Okay, that's how this, and people started calling it Maiwan, the way we call it as Xerox instead of photocopying, right? So that's how it is. And then we have insulated wall panel construction using shotcreting of concrete. We have light gauge steel or cold form steel construction, precast, prefabricated, and then composite. I just run through very briefly into this, right? When in 2010, we have designed structures for Bangalore Development Authority, stating that there is no need of brick masonry. We convinced them in constructing about 10-story building, 6-story building for them, yeah, with the various thicknesses of walls. The beauty of this is you can pour the wall and slab together on the same day. Okay, and it's a self-compacted concrete. Okay, that is the beauty of it. There is no need of plastering later on, right? And these walls are called as load-bearing RCC walls. Load-bearing RCC wall, they're as good as shear walls. They will take the forces of wind and this thing, and earthquake also, right? And this is how we have convinced the AP state government to make this EWS housing, which is PMAY, with this monolithic construction, and they built about 3 lakh houses, and you can see these beautiful houses. We also advised them, similar to IIT Hyderabad, that there is no need of painting, but then they said people still have to come up to the stage of acceptance, so better do the painting. So that's how we have done this painting on this. But then for all these buildings, we have raised the bar of specifications of providing vitrified tiles, okay, and then UPVC windows rather than the normal type of the buildings. So we told the Chief Minister, let us stop constructing the ghost houses, let us build durable houses such that people can stay in that and then remember your name for generations. That's how the buildings have come. Sometimes you will get an opportunity to talk to the Chief Minister who gets convinced, and then that's how those buildings have come up. Now, here you can see insulated wall construction. So what we have done here is an 11-story structure in Angul, Orissa, okay, for JSPL. they are the steel manufacturer, they are building a structure. Then we said, they also have this particular polystyrene with reinforcement on both the sides, which is impregnated through. And then we said, this can be used as a shear wall itself, okay, the wall, RCC wall. And we have demonstrated that and then tested it, and it worked fantastically well. And with this, they have also built, okay, 4-story structures with the help of this particular one, okay. And you can see that you can erect it, and then after doing the shotcreting and painting, you don't see the difference at all. But then there is a massive difference of 4 degrees centigrade temperature difference between outside and inside in the summer. That is the beauty of these structures. Light gauge steel, again, Jindal Steel and Power Projects Limited, JSPL, for their employees housing in Raigir, okay, we have built again a 4-story cold formed steel structure, okay, and then putting the rock wool inside and then cement particle board, okay. Abroad, when you look at these buildings, it is like they put some 2 layers of plywood as a flooring unit, but then it gives sound when you walk on the top. So we have decided here that we put the concrete slab on top of that by putting the deck sheet, okay. That's how these buildings are built. You can also see that this is the bracing with, again, the cold formed steel. Cold formed steel is usually, we use up to 1.6 to 2 mm thickness, right, with the channel sections, and then cement particle board on either side with rock wool inside, which will give you a sound insulation as well as a fire insulation, right. And then composite construction, right. This is again a well-known concept. America and other developer countries do a lot by using this steel instead of concrete. Steel columns, steel beams, and then the deck sheet. On top of that, put concrete. Instead of this particular thing, now we have started putting the precast hollow core slab also, right? Instead of the deck sheet and all, we started putting the hollow core slab on top of the beam. And then I will show you some more ideas which have come up called as a delta beam, where we are putting the hollow core slab at the bottom flange, even giving you the optimization in the space, right? So this is how and we have built one structure in Numaligarh, where the people wanted the building in 6 months for both nursing college as well as hostels, okay?
In Assam.
Yes, okay, Numaligarh. Okay, there you have the refinery there, right? So nursing college, come hostel, we have built this building, and they wanted the building in 6 months. So we have constructed this, but then again, you can see that this is a 12-meter high, is a dry partition. No concrete or anything. So you have rock wool inside, and it's a galvalume sheet on both the sides. We have fixed this 12-meter, made in the factory in Delhi, shifted out to Numaligarh, and then simply fixed it to that. 12-meter height at a stretch. Okay, this is the beauty of it, but totally a drywall construction, right? But we have used only the brick masonry in the toilets, because in the toilets it's not a good proportion. We have used that, right? And then there is another smart guy. This guy is a postgraduate in ISB Hyderabad. He thought of doing something else differently in construction. So he took me once to Australia, and what is called as perma wall form construction, it is coming up. This is made with plastic, right? It is made with plastic. So it is all like you have this plastic sheet, each of this plastic sheet on one side and the other side, and then you will be putting this particular thing, particular ribs inside. Okay, this is also a technology which has come. We have already built some, and he is doing quite a good number of buildings for Mahindras in Chennai right now by putting up the fabrication there itself. Okay, and then what you do there is this PVC foam, whatever is there, it remains there. Okay, whatever the color you want, and then you are just pouring concrete. You are putting the reinforcement into that. It acts like a shear wall, nothing bad, right? So it is a stay-in form, and then the concrete can be poured into that. So these are the different ways in which you can build this. I've seen in New Zealand and Australia, a lot of construction is going on with this. Okay, a lot of construction, right? So there's a beauty of this particular thing, and it is picked up in India also. Glue laminated timber. Anyone knows about glue laminated timber? Any idea? The name itself says glue is added between the timber pieces. Okay? So by adding this, you can make a timber beam of size you want. You can make 1 meter, 2 meter, 3 meter. We have designed one big shopping mall of about 100-meter column free space with the help of this glue laminated this thing, making a big truss. What you are seeing trusses here, we have made it a 100-meter glue laminated timber truss. Right? So there is a beauty.
For the Indian tropical weather,
Sorry?
how is it
Yes.
suitable for the trop? That means some treatment has been done.
They do the chemical treatment and send it. They ask, New Zealand people will ask, what is the treatment you need? How long should it be maintenance free? They do the treatment and send it. Right? It's all 45 mm piece each of these, and then glued together with a strong glue, strong adhesive, fantastically glued together. And thereby, they are getting about 17 to 20 Newton per mm square flexural strength. Right? Whereas our teak wood maximum takes about 5 Newton per mm square, and it is increased to 17 to 20 Newton per mm square, and that is a fantastic value. So, right? Using this glue laminated timber also, the churches are all built in the Europe very much, and swimming pools are also built. We have designed some few swimming pools and structures, bridges like this in Dubai at various locations and resorts and hotel places like that.
India, what is the issue regarding the termite treatment?
Termite treatment.
This is termite treatment.
Yes, chemically treated and sent, such that the termite cannot penetrate into that. Okay? The specifications exist. Right?
So, but those treatments will be limited to 5 or 10 years only, no, sir?
Sorry?
Most of the termite treatments are limited to 5 or 10 years only, no, sir?
No, here they are giving a guarantee of about 20 years.
Okay, sir.
Right? So New Zealand specifications, they ask you how long do you want this. Okay? So we have to specify what is the maintenance period also. Right? One of the important things that I tell you is, while we are working in Dubai, okay, whenever the client comes into our office, we ask him first of all by giving a checklist, what is the first maintenance period you are looking at? The first maintenance period, it is 5 years, 10 years, 15 years is what we ask him. If he says 15 years, we choose the material like that. Right? If he says 5 years, the material will be less costlier. Right? So that is what is missing in India. That is what we should be doing it. Right? So there, of course, they're much richer guys. Right? They can pay for it. Some people will say 10 years, some people will say 15 years, some people will say 20 years, you can forget about the building. Thereafter, he can touch for any maintenance. That is the way we provide the specs, and then he signs on that. Right? Now, we'll come to precast. Now, with our effort of the society and all, we have seen that about 50 companies have come across India. Okay? That is what we have done from our side. Yeah? So many companies are there across India like this. And some developers have also set up for them, like Soba developers, Brigade developers, My Home in Hyderabad, like this. Right? So, what is the beauty of precast? The beauty of precast is large column free space. We can provide floor slabs for about 15 to 20 meters long. That is the beauty of it. Right? Because of this, right? These pre-stressed precast slabs, solid or hollow core, are different slabs as we are going to see now. So that is giving us a fantastic column free space which is needed for the shopping malls, office complexes, and all those. Right? So here you can see that this is a double T slab in the shopping mall. It is also extensively used in the parking structures also, such that the car parking becomes easier, right? And then the beauty is that I could see a column here of 10 meters, but this span is about 25 meters, right? 10 meters is this space, but 25 meters is this space with a double T slab. That's the beauty of the precast, so that he can provide the racks wherever he wants. And now we are also now doing by putting the coloring compounds, we can also do the precast with the coloring compounds, whatever the color you want, you can put it and then do that. Abroad again, the facade elements are most of the time are done with color. facade element. There is a beauty of it. There is no need to do painting, right? So this is how the Dubai mushrooming of the buildings have come with a precast technology. While I was there in 1995, landed in Dubai, by 2000, 1995 to 2000 period, even a 30-story structure was taking about 6 years time to build in Dubai, okay, in 1995. By 2000, even a 60-story structure is being built in about 2.5 years. That is the result of precast, right? So in 1995, they were predominantly using the conventional construction of putting the formwork and all. It was taking time. By 2000, precast companies have come, okay, from abroad, the people have come and set up, and then the mushrooming of structures have come fantastically, right? Even a 60-story structure is taking 2.5 years like that. There is a beauty of the advent of precast which has come into, right? Now, this is how the buildings are built in abroad with beautiful coloring compounds into that. You can see the beauty of it, right? It looks like some stone is just brought and put there. So that is the beauty of the precision and the quality of the precast buildings built there. Yes, connecting to that, yes, in India also we have built. You can see that this is the Jindal University at Sonepant, right? So what the architect have done here is similar to IIT Hyderabad. He has exposed the concrete as it is like that. He has also put only the railings color, right? But then, as we go into this is how the building looks like. This is how the interiors of the corridor, but only in the inside of the rooms only, they have done some sort of a painting. But other than that, the gray color, concrete color surface itself is good enough, and it is being concrete is most impermeable. The water will not penetrate, no need to plastering. Okay, there is a beauty of a precast. Now we have about World Trade Center in Pune, 16.5 lakh SFT being built by Precast India Infrastructure in Pune. We have this building, 1,65,000 delivered in 4.5 months in Hyderabad. Right, again BDA project, BG Shirke have done this particular building, okay. And then hospital building just built in 4 months. See, the time period is reducing. Novotel IBC Combo Hotel Chennai, they built a precast building totally. BME Precast is the one which have built it, right? Canteen block just built in 38 days. A school, if you want, is built in 28 days, just means 1 month, right? So this is how the beauty of the time cutting short of the building. This is one beautiful building, yeah. Infosys thought that building should not look like simple boxes, but they should have some architecture. It is just a parking structure, okay, but they have employed about 3 architects from America, Germany, and UK, and out of them they have selected one design and applied to this. So it looks like a honeycomb coming from outside looking like, okay, but then the building is such that it is 4.5 lakh SFT, total number of basement plus 10 floors structure, right? And yes, it has precast columns and then precast slabs, okay. You can see the corbels and all, but then they have also thought they will not be able to catch up with the time if everything is precast. They have done for this lift course and all with again cast institute, but other things they have done it, okay, because they are importing, transporting all the elements from Pune into Mumbai. They can get it only in the night in Mumbai, not in the daytime, right? So this how these elements are, which you can see it here, right? These elements are such that you can see this one is a concave, other is a convex element through which the air will pass into the building, okay. You will get the lighting also in the daytime, no need of lights in the daytime. That's how the concept is taken up, okay. And then they are simply put into the, these are the fixtures which are provided again to the precast beam. This element will just go and get locked into that, in a free manner, right? So this is how the building is, fantastic building. This set of buildings can only be done only in precast. Cast institute is absolutely impossible, right? This is how the buildings are. Right. We'll just move forward. I think you have been taught about already. I'll just very quickly run through the way forward, the way I want to deliver it. Right. We can see the rectangular L-shaped beam, inverted T. Astro beam is predominantly for bridges. And L-shaped beam and inverted T beam, we use it for the precast slab. Right. So the design, the precast walls, which we do provide the sleeves such that you can do the grouting. And then at the slab level, again, we leave the reinforcement such that it can be tied with the structural topping, right? And then we can do a 5-story precast column, or you can do a 3-story precast column, leaving the reinforcement there for the beam reinforcement to come and join. So in India, we are promoting to do the joint only with a cast institute. Cast institute, no mechanical fixture, we're allowing. That's how you can see that. The beam will come and rest on this corbel, but the beam reinforcement will go into this column. Column is already a 3-story structure. It will be connected here, a 3-story structure, again a 3-story structure. But then the 3-story precast column, at every beam junction, we have left it to open that the beam reinforcement can come. Then we can provide the shuttering with a bell mouth, put the concrete into that, right? This is how the thing, but most of the time, we can see in the conventional construction, a lot of time is taken for our conventional shuttering for the slab. Conventional shuttering, we need lots of carpenters. Whenever we do, then to take it out, we require a lot of time, 10 days, 15 days, like that. Okay, so in order to avoid this particular thing, what we have got now is different types of slab, what we are calling in precast as a hollow core slab, but then in the conventional, again, we have come up with this system also, with the balls keeping in, saving concrete within, okay, and then we have the grid slabs, and then we are looking at PT slabs, like these different slabs are coming up. There is a PT slabs, which is again used by the developers for the office buildings and all. It is also there, much in use in Hyderabad and elsewhere throughout India. But we are dealing with precast hollow core slab. Again, precast hollow core slab. Why is it a hollow? Anyone have the idea? Why is it a hollow? Why do we make? To remove the?
To reduce the dead load.
To reduce the dead load. But why we have to make a hole? What are the advantages? What are the disadvantages? One simple thing is, below the neutral axis, we don't care for the concrete, right? So we are taking the concrete out from there, right? So only the steel will be there, giving the protection to the strands that we are keeping. The top 35 mm, whatever I am putting, is sufficient for my compressive strength. There is a simple philosophy that they have adapted. They have invented a machine and then started producing the hollow core slab, right? Again, double T slabs and all require huge depths below, but then they will go for about 22 to 25 meter long, okay? Beyond that, if you go about beyond crossing 900 depth, then the flow rate also becomes an issue, right? So we use it predominantly, say a single T or double T, mainly for parking structures and shopping malls, okay? Predominantly, that is the usage which goes into that. So this is how the hollow core slab, which goes into that, right? And then we provide the structural topping. You have been covered about this already. I will not dwell much into that. This is what we are talking about. Your stress block which comes in there, we can take out that particular concrete here from that point.
Previous slide.
You want the previous slide?
Previous one. You have
Still previous?
the site image.
Sorry?
Actually, it is a load bearing structure, a wall bearing structure, no, right? Load bearing structure, right? Not
Yeah.
frame structure.
Yeah.
How did you manage to do precast here?
What is the problem?
Sir?
What is the problem? I can put any slab. Just like the normal slab, we can also put a hollow core slab. It's a one-way slab. Hollow core slab is only a one-way slab.
Okay.
Right? Now, when we are talking about, just now I talked to you about Maiwan construction.
Okay.
What is happening in Maiwan construction is that the slab load is coming directly on the wall.
Yes, sir.
Every millimeter space of it, it is getting the load. It is like a UDL. I already said it is load-bearing RCC wall, right? Similarly here also, when we are putting the slab over the brick masonry, okay, that takes a UDL form.
Okay, sir.
Okay, the load of the slab is distributed and every millimeter run of the brick wall.
Okay.
It will transfer the load.
Sir, but there we'll be having connection between the wall and the slab, sir. But here only slabs will be connected.
Yeah, okay, good question. I will come to that as we can go through the steps. Very good question. And now I could understand your question. Right? So, this is a structural topping which eventually gives you the diaphragm action, what we are looking at. Okay? And then there's the various connections. Right? Now, what we are talking about is, you are talking about, see here we have these connections. Yeah? So, over the brick masonry also, we put this to an extent of 80 to 100 mm on either side, and then put these tie rods inside, okay, and then pour the concrete. Okay, then the slab is together, all individual units. That's it. Okay? Right, this is how the precast hollow core slab unit. You can also make the openings if their design is perfectly done. This is what we do to run the services and all that. Right? How many of you are from Hyderabad? Have you seen the precast company factories here?
Yeah, there was a field trip on last Saturday, day before yesterday. We went to
Precast. Oh, wonderful. It's a good company.
And before that, Mr. Sridhar Rao spoke about Animatic.
Okay, wonderful.
That was, of course, an online presentation.
Superb.
Talked about this construction of the hollow core slabs.
Wonderful. Good. Well, then I will quickly run through this. This is double T slab. Yeah, these are transported like this. And Precast have done this double T slab for Nijam club at Abbott's, at the assembly point. Okay, they have done this particular one. Okay, they are the only people who have done this. At hollow core slab, I will try to skip in. You can also cut, this hollow core slab is not coming up to this. You can transfer the load onto the side elements. Okay, and then you can increase the number of strands into that. Right, you can also fix your fixings to the hollow core slab, not an issue. And then there is another slab which is coined in Dubai, is usually called as Emirates precast slab because they have coined it. They have simply said these are the elements which will have the pre-stressing stands similar to hollow core slab, and then at the bottom it is just a 50 mm thick concrete with the normal concrete. Okay, and then they have a shear link which is opened up, which is coming out of this rib. A shear link is coming up, and then they have put the reinforcement against structural topping reinforcement on the top. So this polystyrene is covering this gap. It is like, okay, thereby it is like a composite slab. And this reinforcement, whatever is putting, and this shear link is going and joining the beams which are connected there. So in Dubai, some of the structures felt this is far better one than the hollow core slab itself. It will have more rigidity, and then they started using this. Okay, this is also widespread in Dubai, right? So there are some of the details of that particular one. And then we have the normal castage too. It can also be done precast. There is no need of we are not putting any pre-stressed wires or anything into that. Anyone can make this, right? This is how this particular thing is also called as a filigree slab, right? They again put about 50 to 75 mm concrete, and the remaining thing they will pour it after installing it on the sides. So thereby, what is the advantage we are gaining? We are not putting any plywood, but we are only just putting the runners, okay, timber battens, right, just to support, because it's only 50 to 75 mm. For the 10-meter span and all, it will try to bend, right? So we are just putting these wooden planks like this, right, which will give the support. Thereafter, we pour the concrete. This is how these particular elements are, right? And people are also doing two-way slabs, two-way precast slabs by putting it over the elements, and then they are running this reinforcement.
We have a meeting with our director, we'll come back.
All right, carry on, carry on, carry on. Okay, so a two-way slab can also be done like this with a half cast all around. Why half cast all around? I can continue my reinforcement here. Whatever the reinforcement have come here, this can be continued, right, after putting it over the beam or walls. So this is also in practice, which you have been doing it, right? So one of this building, in Hyderabad we have done it, where it is stilt plus parking plus 9-story precast building. Again, EWS housing at Dundigal, okay? It's a 550 square foot building. So what we have done here is, there is no need to be totally precast. So okay, what we have done is load-bearing precast walls, and then we put about 7-meter hollow core slabs on top of that. Right? All internal walls, contractor can do the partition walls, non-load bearing. We allowed them to be built on the hollow core slab. Hollow core slab can be designed to have these non-load bearing walls. Right? So this is how this building is designed, and about 14 towers we have done it, and then from your retabs you will get these values, okay, into that, which is fine and fantastic. Right? This is how the buildings are built. 11-story buildings in Dundigal. Right? This is in Amravati, Capital Region Development Authority. Again, they have taken a call that let it be precast buildings, precast walls at certain locations, and then they wanted to leave it open and then decide whether it should be a wall or a glazing later. So they have done this precast column with corbels and all. The structure is done by Preca again. From Hyderabad, they have shifted to Vijayawada. It's about 300 kilometers, right? But then the building is built very fast, right? This is how the building after its completion and all. They are the buildings of that this thing. Now, buildings in NCR. Sometime now, DRDO people have called us stating that they are looking at a durable buildings and a faster construction in about 18 months. 8 lakh SFT we have delivered in 18 months. There is a beauty with the precast, right? So we have got a call. I went there from Hyderabad to Delhi, and these are the buildings. Some of the buildings are residential building. These are meant for DRDO and especially for the RAW, raw intelligence people to stay within this, right? So here also you can see there's a precast walls, hollow core slab put on the top, but then when their buildings are like this, you can experience a bit of torsion and other things which needs to be controlled, okay? These buildings, whatever we have designed, about 5 types, they're all peer-reviewed by Professor KVL Subramaniam in Hyderabad. Because right? There's a model mass participation. Sometimes, if you say this building, it is almost symmetrical, not a problem. Very symmetrical and easy. But if you say the previous building is a bit difficult building, where you will get the torsions and all, right? And then I'll show you some more non-torsional buildings also. Even this building is a bit tough. When you can see architect struggles to cover his areas like this, to minimize the balcony areas like this, because he has been given a task of a type 3 building should not be exceeding a so-and-so square foot. So he struggled to put the area, right? But then again, the building which is coming up like that, in this building, it is not like only the shear walls with shear connections. For some walls, we have gone with the monolithic connections also. So building can have shear wall, shear connections and monolithic connections. Why 2? Why not 1? Because sometimes I have to give the longer wall. Let us say you have a wall of 10 meters long, 10 meters long. 2 5 meters are clubbed together. Then your moment of inertia of the wall is more. If you say only 5 meters, okay, is all the time BDQ by 12. Your length is only 5 meters. If you say 10Q, then you get more flexural rigidity. So resistance will be more in resisting the wind and earthquake forces. So in this building, we have done like that, but the contractor cries whenever we provide a monolithic. This is how the buildings are built in DRDO, the precast buildings, right? Buildings after completion. This is one of the buildings done by my friend Bob in Ghaziabad. Is again a building of a 12 to 16 story buildings, totally load bearing and hollow core slab buildings, right? And then we have done one building in Hyderabad. A project is called as a Magic Breeze. This building is a duplex story building where each one is an apartment. Like this, you can see from here to here one apartment. Again, from here to here one apartment. Like this is a duplex story apartment. But then the building is such that planned in this manner. But then we had a chart with the architect saying that it needs to be connected here. Otherwise, these 2 independent buildings are difficult to control with the torsion and all. So we need to understand how to control the torsion of the building, right? And then negate that particular aspect, right? And this building had one particular requirement of, you can see that from the wall we have taken a cantilever beam outside. From the wall itself. Wall is a load-bearing precast wall. We have taken a cantilever beam out of that. Right? But what is it we are doing? The gentleman wanted for the plants to be set up where his requirement is the plants can grow 10 feet tall. Okay, and then he wants to put up a huge pot into that with soil, right, which is about 1 meter high with soil into that, which is a tremendous weight. Then we have decided let there be a precast element which can take the brunt weight of the pots, flower pots, which can grow over there. That precast element, we put it over this cantilever element. Now you can also see there are certain grooves. He said, why the wall have to be plain? So we put in the formwork itself these particular grooves of putting that square tubes and then poured concrete, automatically the grooves have formed. This is how the precast can be done, whatever the shape you want, whatever the design you want, right? Then commercial and industrial structures, right? We have done one building like the industry structures where the government of Andhra Pradesh wanted a building, okay, to let it out for the footwear industry, but they don't know how many people will come and how much space to be occupied. Then we said 12-meter slab, 36-meter span, you can construct a wall wherever you want, right? So a fellow can take 12 meter by 6 meter or 12 meter by 12 meter, whatever he wants, he can construct it, right? And then the building is longer, in the footwear industry people like it being into that. But here, again this building after design and all stable enough, when we have provided the Dextra couplers. You have seen the Dextra couplers at Precast? You have visited the other day. Growtech coupler is providing a big development bar and all that. What we do here is, this is called as a Dextra coupler. Usually what happens, if you are providing a 25 mm bar, let us say, if I have to give that lap length to 25 mm bar, usually approximately 50 times the diameter, you have to lap the bar to develop the bond. But here, there is no connection between this top bar. Bottom bar will just enter into this bar and then we send the grout. This grout has a strength of about M80 to M100. And its bond strength is so high that it is about 8 to 12 MPa, that it is giving so much of strength, the bar is breaking, but the grout is holding it because of the bond strength. We have tested it and then started using this. So thereby, a 25 mm bar, which is coming from the bottom, will just enter into this by 200 mm. That bar will be threaded at the top and goes into this CI shank. This is a cast iron shank of 60 mm dia. The grout will go and hold it. That is the beauty of it, right? Such that there is no congestion. Into this building, we went with the 2-story precast columns and then allowed the precast beams to reinforcement to join into this junction from both the sides. Okay, that's how it is, and then we have concreted. 2-story columns of about 1 meter long by 400 wide is a beauty such that we can save the time and construct it faster 6-story structure. Now you can see one of these building from Pune is about 350 kilometers away. From Pune, this about 1 meter by 1 meter columns, 2-story, by about 9 meter long, they have been shifted and then lifted and placed over there into a precast footing again, where there is nothing. In the 350 kilometers away, there is nothing. So all the elements have gone there. Whatever that they are doing is only the micro concrete or grouting, okay, which will come in the backs, which is easier for them.
Where was the factory? Your factory?
Pune.
In Pune.
In Pune. From Pune, it's again 350 kilometers away. Okay, so that is a beauty. So precast can go miles, is a beauty into that. Yeah, you can even build precast compound walls also, various compound walls with the footing again. We have done one pharmaceutical building again. They wanted in 6 months. Well, we have delivered in 7 months. Even that 1 month delay is because dewatering has come too much in their foundations, which they have not anticipated, but there is only 1 month delay. Here you can see a 3-story precast column, 1-story precast column, where a cantilever beam is projecting out. We have used a 1-story precast column. The reinforcement whatever is coming out, this beam when comes and sits on that, it exactly matches to that. That is the precision to which you have to develop the drawing and do the casting in precast, right? So that's how these elements are done. This is a 3-story pharmaceutical building. Later on, architect will cover with his beautiful ACP cladding. Even industrial buildings is a beauty to see how nowadays how the architects are giving a beauty to the labs, right? Into the industrial structures also, removing the steel PEB buildings, we are going with precast columns, with corbels, with pre-stressed precast beams, but on the top, we are providing the jet purlins and the galvalume roofing sheets, because that is cost effective, cheaper on the top. Hollow core slab is a heavy dead weight, no need to put the cost also. So this is one way which we are going into that. This is a Coca-Cola factory. Again, here they have done an 8-story, 24 meters high precast column, 24 meters high precast column, right? And it is weighing about 88 metric tons. 88 metric tons. They thought of doing 3 meters and all, every 3 meters of pour, but then Coca-Cola was told that we can erect this particular thing. But then,
column is 88 tons. Each column is 88 tons?
yes, each column is 88 metric tons and 24 meters high. And special trucks were formulated for that. And then they have lifted it and placed it over there. And then I will show you, again, 28 meters long, a precast beam, which is 132 metric tons again. 132 metric tons again. So the beauty of precast is how long and how bigger I can make, such that I need not attempt too many elements to handle. Okay, if I keep on making every 3 meter a column, too many elements to handle. Okay, let me use the bigger crane, lift it and place it there. Then the building will be going very faster, right? So this is how the elements are built, right? Again, the parking structures, even we are doing the precast water tanks also in Odisha, just to convince the Odisha government. We said we will do this column right up to the top. That is, no, just like the way Cast Institute goes, immediately it shows like that, later on you can go. So we can do this precasting like this also. Even by doing it like this, they have saved about 4 months' time instead of putting the shuttering and all that. But having done that, now in L19, one lady engineer has come up with this beautiful idea of making this precast water tank. What is that innovation that she has done? She has done an H frame. This is an H frame, which is like this. And this same H frame is coming here. It is sitting on the top, right? We can see that this bracing is not coming at the same level, because this H is going there at a different level. So this is crisscrossing, right? So this is one good way of doing it, and we are able to construct this whole thing like this as a H frame with the dowels and all going in, and on the top precast slab again, and on the top they are putting the galvalume tank, GA tank. Nowadays lots of GA tanks are coming up which can give 25 years warranty, which is done like this. Now throughout India we are also using this for a number of structures like this, right? Piles are also precast. We have a factory in Narsapur, Andhra Pradesh, right? They are also doing the precast piles, precast spun piles. It is hollow inside. So that means what is spun, this is how the element comes in, right? They put the concrete and then just spin this particular thing in a very high speed. Then the concrete will segregate and go to the edges and thus form the hole which is there inside like that. Okay, so with the help of this they can make a 60 mm, 75 mm, the different sizes, different diameters, and this can be used for piles again. We have used this for some of the structures in Andhra Pradesh, right? Just skip this, and then there is this is how the buildings are precast. You can make what are your precast boundary walls, precast industrial structures, right? So whatever the shape you want, this can also be done, not necessarily in Cast Institute, right? This is what I was talking about, an industrial structure. This can also be like here we have done precast, see the structural steel beam, but precast columns, precast walls all along. Okay, here sheeting will come on the top, right? Only for the ventilation purpose and all. This is one type. And then within that, if they want mezzanine floors, again precast slabs can be sit into, right? This is how the precast industrial structures can be done. Is again a precast factory for Nestle company who manufacture chocolates. And then here you can see, even we have done the pre-stressed precast beam. We have put only the jet purlins on the rooftop. And on top of that, the galvalume sheets will come. In the sports stadium, right? So easy to make an L shape like this and then put it over the gutter. Okay, so the precast element, you can also make these precast beams to come like that. Right? These structures are done in India, Ahmedabad. Right? And trussless roofing system again is again the whole structure is made in precast. Only the roof is made in sheeting. This sheeting, how many of you have seen? It does not have any steel beams. It's called as a trussless roofing system. It has a profile, but the sheeting can come like that. It can span about 30 meters like that. Okay, 30 to 40 meters. The sheeting has also come. Okay, and then between Mumbai and Ahmedabad, the bullet train system is coming. The bullet train goes with so much speed that it gives sound to the adjoining villages. So then it is felt that at every village, there is a need to construct boundary wall to an extent of 1 kilometer on either side of the station. So L&T have picked up few precast companies in Mumbai and Ahmedabad, okay, about 5 companies, and they have started putting precast foundation, precast compound wall to get it erected there. Their project is 5 years. So much of precast. Number of precast companies have immediately sprung to that location. Number of entrepreneurs have set up and that. Boundary walls, yes, we can also do boundary walls with whatever the color you want, whatever the design you want. Just on a table, pour concrete with coloring compound, you will get the design, whatever that you want. Okay, that's how the precast boundary walls. And this is Acotech light walls. Yeah, there is also a factory. Have anyone of you visited?
Sri Lanka? Acotech Sri Lanka. Because we had a presentation as Acotech Sri Lanka.
Acotech people have come and given a presentation. We have a factory in Hyderabad also. Right? From Hyderabad they are supplying to Chennai, even Bangalore, in Hyderabad so many buildings. All the non-load partitions they are doing this for all the offices and all. You can also visit this if you have time. Right? So I'll just skip this. And then there is one interesting thing. Okay. One requirement have come to us that in Russia, one country were trying to provide transmission towers for thousands of kilometers, right? And the distance between transmission towers is like 60 meters. But then these transmission towers are such that it will have 4 legs. And you see, each of these legs, whatever that you are trying to see upwards like this, it will have a foundation at the bottom, 6 meter by 6 meter. 6 meter by 6 meter, such big foundation, right? And then this is how if they do it in Cast Institute. 6 meter by 6 meter, and then a pedestal will come, and then from there the column will shoot up, and from that column again the steel column will shoot up for that angle. This is how the system. But they said it is a pain for us to go on doing this every 60 meters for thousands of kilometers. Can you do something in precast? They said, I said, okay, 70% precast, 30% cast institute. They said, no, we want totally precast. Then we did brainstorming and all, but then they also put up the clinks like the weight should not be increasing more than 7 tons. Okay, because around those areas where sandy tracks are there, only small mobile cranes can go. Bigger cranes, if they go, they will get stuck. Hydra element can go, it can lift about 5 to 6 tons is the thing. Now what we have done, a 6 meter by 6 meter foundation, we broke it into 4 pieces, got them connected there with the dowel connections, and then the top portion, whichever is coming there, again broken into 2 pieces, got them connected with the dowel connections, okay? And then the top portion, whatever you are looking at it, if you can look at this top portion, this portion is such that it comes up to that, and then this portion is coming in the RCC column like this particular one. Again, you have the dowels like that. All these are interconnected and all that connection. Then the people, then they said, please test it. Right? Now you see the loads that are there. Uplift is 3,812 kilonewtons, 381 metric tons. That's a huge load, uplift, which comes on that. Right? That is uplift. There is a shear force, longitudinal shear, compression is this. We have to test everything of this. Right? So after doing all this, then of course, Arena is one software. Some of you can use it who are doing PhD and all. Wonderful software developed by one professor, PhD professor from Czechoslovakia, and our professor C.B.K. Rao from NIT Warangal used this software. He has done the way we have done the precasting exactly, and then applied the forces to see what is happening there, okay? And then the stresses that it has produced, the way we have got exactly matched there, okay? No failure anywhere. We also shown this to the people who have come from Russia, right? And then we have tested this. So in order to test it, this element, we have taken in the precast factory, there are certain huge boxes of boxes are there. This is Professor Kameswar Rao, this is myself. About 1.8 meter, 1.8 meter, 3.6 meter box is a shear box which is used for the tower cranes, okay? And then where we are applying load, then it may buckle. Then we thought we put wrapping with the angles where we are going to apply the load. And we have one more professor, Professor Gunesh Rao. This is me actually. Right? And then this is set up like this, and 2 elements independently. See the testing system also for precast, right? Elementary, and then we applied the load on top of that, transmission tower, right? And then it has succeeded, taken the load the way it should come and all that, right? So precast is there into transmission towers. Now the biggest project, what I can say in the entire Asia is coming up now, is a 46 basements down, 38 story above precast structure being built by my home, Here again, 12 meter column free spacing, hollow core slab of 265 thick is a project called Greva. Had I come to know, I would have sent you people to watch the structure under construction. Already one tower is completed, another tower is nearing completion. That is the first phase. Okay, is like this. They are going to build about totally 34 million square foot of leasable space. That is a big idea of totally the precast structure which they have come, right? And then a huge setup of precast factory over there, which you can look into that there. This is how they have done these walls, various elements, and sometimes for flower pots and all, they're using the ultra high performance concrete, okay, for flower pots. And they have used the stainless steel bars in the flower pots. The reason being is that being a flower pot, it may get water and the concrete may get damaged. So they thought it's better to use a stainless steel bar and then this, and then they can forget about its damage throughout its lifetime. Like that, they have done some innovations and they are using various type of ultra high performance concrete, UHPC planter box like this, right? This is how these particular buildings are, right? The precast plant, some of the buildings, I think this Preca might have shown it to you. It's a wonderful building that they have built in Odisha, right? For Sri Sri, the meditation center. The beauty is that whenever you see this building as it goes up, okay, I have taken this Odisha government people over there, right, into this particular thing. Here they have taken the column and beam casting together. Column and beam casting together such that they can maintain that alignment. Again, this column going like this, beam coming like this, jointing is going to be a big problem. So they put both of them on the plan like that, casted it, lifted it, and then do it. So there's a beauty of another structure. So like that, it has come, beauty of this thing. This we have seen it already. Thank you very much. Any doubts? Questions? Most welcome. I'll not bore you much with design because I'm being told you're already given a lot of design inputs, but I've shown you briefly about design, but the various development, various structures which have come up.
Where were you in Dubai, sir? Which company were you in Dubai?
Which company?
In Dubai were you?
All right. I have worked with W.S. Atkins, Balfour BT, Engineers Office, like that.
Balfour,
Yeah.
but you.
Rest, I worked with.
I work for ADNOC.
ADNOC. Oh yeah, beautiful company.
10 years with ADNOC.
Okay, good, good. Yeah, please.
Sir, in the car you recommend, sir, there you left a gap for just reinforcement, no, sir, for pouring concrete, no, sir. Like this
Sorry?
picture, sir. There is a car bell, here beam will come, here slab will come, no, sir. You left here as a free space, no, sir. Here there is a self-weight of the concrete there, no, sir. It will tends to like tilting, no, sir. It may happen or not, sir. Like here it is only reinforcement, here with concrete, sir. There is a self-weight of this.
So
Due to the self-weight, it may leads to
you have to take care of that during your transportation carefully.
okay, sir. Or else if you fully concrete, that means what will happen, sir? In a side factory.
Then I have to leave the beam reinforcement outside.
So that's why we are using carbels in now, sir.
No, see, this beam reinforcement have to come inside. Isn't it?
Yes, sir. Or else we want to give a
Yeah, otherwise from a column I have to throw this and then half cast this beam, do the concrete in there. Either way.
okay, sir.
So you have shown some slanting structures, like in temples, if a structure is like this slanting, if the slab is here and the structure is like this slanting, means how will you place this, sir, in precast? Like facades and all, it is like slanting structures now. How will you place it against the gravity?
Now I've shown you one this thing, one temple.
Yes, sir.
Okay, it's almost
Temporarily,
temple. So that fellow I have done this whole element as one.
As one, okay, sir, okay.
That is one way of solving it.
Okay,
Okay, it is better always. The junctions are very tricky ones.
okay, sir.
You better cast this element as one,
Okay, sir.
right? We also cast the column and beams together junctions. Okay, column and beam together junctions, and then allow the precast beam to come up to the point of contraflexure. Do the concreting there sometimes when the span is bigger, because they are the junctions which are very problematic. Okay, sometimes we are going like this column opening, concrete can be poured. Sometimes we don't do that, column can go, okay, and then reinforcement left out to come and join to this beam. It can be done either ways. Nowadays we are also adapting pre-stressing also. Okay, that is also another easy option. So many details can be worked out. So thank you very much. No more doubts? Thank you.